is about radioactivity and radiation. So if we talk about radiation, typically we're talking about the electromagnetic spectrum. We've talked about this in the lecture a number of times. Just to remind you, the low energy end, that's like radio frequency, stuff like that. There's microwave. Then there's infrared. Then there's the visible region, red, orange, yellow, green, blue, indigo, violet. That's the visible region. Then there's, of course, ultraviolet, X-rays, gamma rays, and so on. All right? And so this end, starting here, this is ionizing radiation. And ionizing radiation is radiation that can remove electrons, break chemical bonds. All right? Now, this is supposed to be an R, by the way. Red, orange, yellow, green, blue, indigo, violet. We even dealt with the visible region in the lab on chromatography. Anyway, what you're going to look at is really this stuff today. You're going to look at some stuff under a black light. And so just going through each part of the lab, the first part of the lab, you're just going to look at some stuff under a black light. So black light, for those of you who have hippie parents, and yes, I own a few black lights myself because I'm an old hippie. A black light is UV. And so what's cool about UV, if you ever looked at things under a black light, you'll see that they look very different. And that's because what that can do is you can use certain types of dyes that are fluorescent. And what these fluorescent dyes will do is they will be activated by UV, and so UV will make them glow. And typically they're invisible under regular light. And so, for example, when you look at money under an ultraviolet light, you may see some lines. It's designed to prevent counterfeiting. Frequently, we use things in detergents. We might use some UV, some fluorescent dyes in there, just because it'll reflect more light and it'll make things look whiter. All right, and whitening toothpastes are the same way. So when they reflect the ultraviolet, you'll see kind of a whiter light. And some other things you're going to look at, you're going to look at atomic spectra. So this is activity 2. So that was activity 1, and then activity 2. And I'm providing you the data. Activity 2 is we're going to look at light through a prism, actually activity 3 as well, through a prism. And what a prism does is it just breaks up the light. You've all seen the t-shirt from the old Pink Floyd album, Into the Spectra. And so what you should see is a rainbow. Now, of course, you're not doing the lab, so I've provided the stuff for you. Let me erase all this stuff here real quick. All right, you can hit pause if you want to see it. Whoops, erase that button. The activity 3, what you're going to look at is let me just finish erasing this. Using the button just to clear the whole thing. Okay, so for activity 3, you're going to look at a spectra from elements. And what you're going to look at is when you take neon and you give it like a neon light, you give it energy, and then you look at that through a prism. And what you'll see is you'll see a very specific spectrum. Instead of a rainbow, you'll see a handful of lines. For example, if it's hydrogen, we actually have hydrogen. Hydrogen gives you 3 lines. This is the prism, and you'll get 3 lines for hydrogen. You'll get kind of a red, kind of a blue-green, and like a a violet line. And what these lines are caused from, these are due to electrons moving between energy levels. Remember, we talked about electrons live in layers. So if I have an electron here, and it moves up to here, when it moves back down, it will give off light. Right? So all this stuff will show up in these spectra. And what's interesting is that these spectra are like fingerprints. Every element has a unique spectrum. So if you look at a star that's 50 light years away, how do you know what it's made from? It takes light 50 years to get here. The same idea, you can look at the spectrum. All right, I'm going to hit pause. I'm going to stop this video. I'll make a second half for the rest of the lab. I'll just stop it right here.